Okay, hello everybody. Thanks for joining with me today. Today we're going to discuss a little bit more in Chapter 2, Section 3. This is the last video that we're going to have in Chapter 2, Section 3, and it's going to talk about what an even and an odd function are. So let's get started. So throughout this section, we've studied different types of symmetry of a graph. In the terminology of functions, a function is said to be even when its graph is symmetric with respect to the y-axis, and it's odd when the graph is symmetric with respect to the origin. Now, I want to pause kind of for a second and kind of highlight here a little bit of what this is. Even means it's symmetric with respect to the y-axis. So let's talk about what that means. So you can see here, and it's the easiest way for me to show you is to visualize what that means. You can see that I have a graph of y equals x squared. And what you see here is the y-axis and then the parabola that's facing up, because this is just the basic graph. Now, what it means to be symmetric with respect to the y-axis is both parts of the graph, the part to the right of the graph and the part to the left of the y-axis are both the exact same size and shape. And the way that you can tell something is symmetric with respect to the y-axis, the easiest way is to simply flip this graph over, or we would rotate it with respect to the y-axis. Now, when I do that, what you see is I end up with the exact same graph. So I can take this graph, I'm going to do this one more time, I'm going to rotate it with respect to the y-axis, and I end up with the same graph. That tells you that this is symmetric with respect to the y-axis. If your graph looks like this or some other variation where you can rotate it and get the same graph, that is an even function. Now, there is a way to test for this using algebra, which is what I'm going to show you here in just a second. Now, in a similar fashion, we have odd functions, and what it means to be odd is it's symmetric with respect to the origin. Now, this one's a little bit harder to maybe understand because it's not immediately obvious what it means to be symmetric with respect to the origin. So what you can see is I have the graph of x cubed. And so it goes up to the right and it goes down to the left. Now this is x cubed. Now what it means to be symmetric with respect to the origin is that you rotate this graph, but we're not going to rotate it along an axis. We're going to rotate it along the origin. So we're actually going to roll it over by 180 degrees. And what you see is the graph itself lines directly right back up with itself. So if I do that again, you can see I have the same graph. So what you see here, this is what it means to be symmetric with respect to the origin. And so if you have a graph that is symmetric with respect to the origin, it is called even. Now, there are ways to test for this, and that's what this box is explaining. We can actually use algebra rather than having to graph something and then look at the graph of it. And it says a function y equals f of x is even when for each x in the domain, f of negative x gives you f of x, meaning if you plug in a negative number, you will always get a positive number out. Now, what this one says is a function is odd when y equals f of x is odd when each x in the domain of f of negative x is equal to negative f of x, meaning if you plug in a negative number, you will get a negative number out. So let me show you how to do this. So what you see is we have this function right here, and this function is g of x is equal to x cubed minus x. And it says it is odd because g of negative x equals negative g of x. So the way that we do this is we take the original function that you can see I have a box around, and everywhere where there's an x, I'm going to put a set of parentheses, and then I'm going to substitute a negative x in. And now what we need to do, once we substitute that negative x in, is we need to see what the outcome is. So by following PEMDAS. So in this case, we're going to take negative x cubed, which doesn't get rid of the negative. It still stays negative x cubed. But what you can see over here is this double negative will become a positive. Okay. Now, I want to kind of focus in on this result that we got right here that I'm going to highlight. If you look at what I just highlighted there, and compare it to the original function, which I'm going to write right underneath of it, is x cubed minus x. And what you see is every single term, they line up, but every term went to the opposite side of how it started. So originally, this was a positive x cubed. Now it's a negative x cubed. Originally, this was a negative x, and now it's a positive x. So all of the signs flipped and became the opposite of what they were. So what that means is this function is odd, because when we substituted a negative value in, every one of the terms' sign went to the opposite of what it was. Okay? I'll give you another example. So this particular function, h of x, it's x squared plus 1. Now I'm going to go ahead and substitute a negative x in to where the x is, but whenever I square that negative x, it becomes a positive x squared again, and we end up getting as an answer the exact same thing that we started with. Nothing changed. Okay? So what that means is if none of the terms changed, then this function is even. So the test is the same for both. It's the result that tells us whether the function is even, odd, or, as you'll find out here in a second, you can also have a neither. So what happens is all of the terms stay the same, and it's even. All of the terms flip their sign, and then it's odd. Or if some change and some don't, then it is considered to be neither even or odd, which means our graph does not have any symmetry. Now, what you can see here is the graph of each of the first two examples I showed you. So this first graph on the left-hand side right here was of an odd function. And hopefully you can see that if we took that and we rotated that 180 degrees, that the graph would line right back up with itself. And it would be symmetric with respect to the origin. The second graph was an even graph. And therefore, if we took it and we rotated it about the y-axis, it would also line back up with itself. So if it can rotate with about the y-axis and line back up, that graph is said to be even. All right, so that's what I have for you today. I would like you to work on some problems, and as always, if you have any questions, feel free to email me. Have a great day.